All right, so this week we have started prime and composite numbers, okay? So this is a little help with the homework and just to get a basic understanding and just kind of jump up a little bit. Prime numbers are any numbers that have two factors, whereas composite numbers have more than two factors. So when you're prime, you just want two factors. And then when you're composite, you want more than two factors. So for like the number 17, for instance, the only way that I can get 17 is to do 1 times 17. So my two factors are 1 and 17. That's it. 1 times 17. Two factors. There's no other way to get 17. But for a number like 12, I can do 1 times 12, right? Or I can do 3 times 4. That is more than two factors. So this number, actually it's 4. This number would be your prime. This number would be your composite. So that's just a basic understanding of the difference between prime and composite, okay? One of the things that you need to know about composite numbers is that they can be divided evenly. So that means that they're even numbers. So composite numbers are usually, well, let me take that back. They're not all even numbers, but a lot of them are even numbers. So many of your composite numbers are even numbers, okay? So that means like a number like 4, 6, 8, 10, 12, 14, 16, 18, 20. These are all composite numbers because they're even. Like, you just know that they're composite. Now, you just have to know how to get the factors for each one. So, for like the number 8, I know it's composite, but what are the factors? 1 and 8, 2 and 4. These are our factors. It has 4 factors, okay? Now, there are some composite numbers that are not even, okay? Those are numbers like okay? Those are numbers like 15, right? 15, 21, okay? Numbers like that, because though they're not even, they have many factors, okay? You can do 1, 15, you can do 3 and 5, right? So that's what makes it composite, even though it's not even. Now, all even numbers, pretty much except for the number 2, are composite. Then you have some odd numbers like these that are composite as well, because you have more than 2 factors. So 1, 21, 3, and 7. That's what makes that composite, okay? Let's do a little exercise, okay? Let's say I gave you a list of numbers. Say we were doing numbers, I don't know, let's do 40, 41, 42, 43, 44, 45, and 46, okay? And I told you all I want is only the prime ones. I will only prime, okay? Now, you can go about this the hard way and start listing factors and figuring out which ones of these are composite. You could do that. So you could take 40 and figure out all the factors and see if it's composite. Or you can use what you know. You know that all even numbers are composite. So let's eliminate all of the composite numbers that are even. 40 is even, that's composite. 42 is even, that's composite. 44 is even, that's composite, and 46 is even, that's composite. So it can't be any of those because they're even and composite, okay? That's the problem. Then you're gonna go back and you're gonna look at these numbers, okay? Let's go back and look at these numbers, like 45. Now here's the thing, you wanna make sure that you do 1 in 45 every single time, 1 in that number. But then you wanna look at it and you wanna say, hey, does this divide by 2? My students know that all even numbers divide by 2, and this isn't an even number, so we know that it's not. But does it divide by 3? So we go to 3. 45 divided by 3. And of course, like always, we list our 3's. One, 2, 3, 4, 5, 6, 7, 8, and 9. Go back and list your 3's. 3, 6, 9, 12, 15, 18, 21, 24, and 27. Now, they won't have to do that for every single one, but for like 45, which isn't going to be on this chart, they will. But if the number was, say, 18, they could just count by 3's on their fingers. That would be easy for them. Don't mind them doing it that way. But for bigger numbers, this is the way I want them to do it. So 3 goes into 4 only one time. 1 at the top, minus your 3. 1, bring down your 5. 15. And you're going to look for that 15 over here. There it is. 5 goes up here. 15 goes to the bottom. And we're done. Guess what? 3 times 15 is 45. So we're going to put 3 there. Can we divide by 4? If you try it, you can't. Can we divide by 5? Oh, look, it ends in a 5, so it has to. Now, kids can do that. They can either do it like this, where they set up the division problem and divide by 5, or we can just use our fingers. 5, 10, 15, 20, 25, 30, 35, 40, 45. Ooh, 9. So it's 5 times 9. Okay? And they can go all the way to 9. So try to divide by. But this is pretty much it. This is it. So since this has more than 2 factors, this is composite. There we go. Let's go to 41 and 43. Okay, we'll do 1 times 41. We know that automatically. Okay, that's 2 factors so far. Then we try to divide by 2. Can't do it, it's not even. Then we'll try to divide it by 3. Here's our 3's up here. So 3 goes into 4. 1 time, bring down that 3. Oh, let's bring down our 11. So 3 goes into 11 about 3 times right there. Okay, so 3, 9. And you're going to get a remainder of 2. Oh, can't go in. Can't go in 3 times. Can't go in 4 times. When I try to divide by 5, 5 isn't going to work. Oh my gosh, I'm stuck. Guess what? These are the only factors. This number is prime. There is no other way we can divide 41. So it's prime. Same goes for 43. When they work 43 out, the same steps going down, seeing if it can divide by 1, divide by 2, divide by 3, 4, 5. They're going to realize that's prime. I'm sorry, that's prime. So your number should have been 41 and 43. Okay, so that's a good way to practice with them. Give them a list of numbers and see if they can figure out which ones are composite and which ones are prime. That's a good way. But for tonight's homework, I hope that helps. If not, shoot me a text message and tell me what your concerns are. Okay? All right.